Just moving on, for those that might be less familiar with the TSB, although there's quite a few familiar faces here, is just to remind you that we are the UK's National Agency for Business Innovation. So we receive funding from BIS, the Department for Business, Innovation and Skills, to help accelerate business-led innovation and stimulate economic growth to help get the economy moving and also to create jobs. So our funding comes from BIS. Our budget for the 13-14 financial year was in excess of 440 million. And most of the competitions that we bring forward are asking ourselves the questions: how can we help UK business to take new ideas and technologies towards commercialisation more quickly? So we appreciate that the innovation process is not easy and it always needs help and support. And this slide is just really to graphically illustrate, if you like, the range of different technology areas and market sectors that we support within the TSB. So along the bottom in pink we have the enabling technology areas, and these help to provide underpinning capability in things like advanced materials, the biosciences, ICT, electronics and sensors and photonics. These are supported through what we term the competency areas such as high-value manufacturing, digital services, space and resource efficiency. And these help to translate these technologies moving towards markets and commercialisation. We see in green, or if you like, aqua colour here, these are the challenge-led areas that we support, and this represents the bulk of our funding programmes. And we have challenge-led areas and innovation platforms around energy, the built environment, food, transport and healthcare. And Callum himself and another colleague, John Whittle, are working in the food, the agri-food area here. And on the right, we have the development area, or the emerging technologies area, and this is helping to take things, exciting technologies, if you like, that are just emerging from the research phase, and ways in which we can help to support their more rapid commercialisation. So an example of this is synthetic biology, which started in the development area, and that's now matured and has moved into the biosciences underpinning technology area over here. So this is really to try and represent the different types of projects that we fund within the Technology Strategy Board. So those that might be a bit more familiar with research councils and how research councils fund, we typically take the outputs of research council funded projects, and we can take those forward through our pre-industrial research programme. So this is typically feasibility studies that can be between 12 and 18 months duration. We then look at industrial research, which involves elements of technology development and demonstration activities. And this has really formed the bulk of our productive R&D programmes within the SAF IP to date. And then building on industrial research, we can take things forward through experimental development, which helps more on the demonstration type activities, through things like systems development and systems qualification, right through to production of prototypes. And this is really trying to help support businesses so that they have confidence to invest and take those technologies and products right the way through to commercialisation to the marketplace, or to help develop a sufficiently advanced business case to look for other forms of investment like angel investment or venture capital investment. So within the TSB and the food challenge-led area, myself and Callum work on the Sustainable Agri-Food Innovation Platform, and this is one of 5 innovation platforms that we're currently running at the TSB. We've got others in things like low carbon vehicles, assisted living, stratified medicines and low impact buildings. The innovation platforms themselves are programmes which bring together government, the research base and industry to address a specific societal challenge, but also to look at opportunities for industry to meet that challenge whilst also growing their business and developing new commercial opportunities. And within the SAF IP itself, we're really looking at the challenge around food security and ways in which we can enhance productivity and efficiency right across the food chain for the primary production through to the food processing and manufacturing environment, whilst also decreasing the impact that food production has on the environment. And this is a co-funded initiative. Our core funding partners are BDSRC and DEFRA, but we've also received funding from Scottish Government and HDB in other programmes that we've run through the SAF IP. And it's a 90 million investment over 5 years. So I'm now going to touch on some of the collaborative R&D projects that we've run through SAF IP today, just to give you a bit of a flavour of where we've been before and where we'd like to be going in the future. And we'll touch on some examples of projects that we've funded to help give you a framework for the catalyst, which I'm going to go on to describe a bit later on. So the first competition we ran was around new approaches to crop protection, and this was really looking at the challenge relating to changing EU legislation around crop protection agents and actives, and how we could develop alternative solutions to help maintain yields around that particular challenge. The second competition was sustainable protein production, and this was looking at the UK's reliance on particularly feed imports like soy meal. We're only 30% self-sufficient in vegetable-based protein for livestock production systems. So it's ways in which we could enhance protein-based crops in the UK, but also the efficiency of conversion of those feedstocks for livestock production systems. The third competition was around food processing and manufacturing efficiency, and this moved into the post-farm gate environment. It was looking at ways in which we could decrease waste and greenhouse gas emissions associated with food manufacturing. More recently, we ran a trade measurement technologies competition, and this was really looking around the new challenge that's arisen through, if you like, the great explosion in genomic sequence data that's come about through the decreased cost and increased speed of DNA sequencing, and that now represents a bottleneck in terms of data. So we're trying to encourage, if you like, ways in which we could measure traits either in the field or measure technologies which would enhance agri-food production efficiency for beneficial traits across the agri-food sector. Currently we've got the engineering solutions competition, which is still live at the moment. We've got full stage assessments being reviewed, and this is moving away from the biological focus that we've had with some earlier competitions. It's really concentrating around things like automation, robotics and precision agriculture type applications, and how that can help enhance production efficiency and meet the challenge of the sustainable intensification of our agricultural system. But again, it moved on into the food processing sector as well. And at the moment, we're at some quite late stages at scoping a competition for later this year, which is looking around the whole issue of the control of crop and diseases. So now I want to go through a few examples of projects from this platform, from this programme, just to give you a bit of a flavour of the types of things that come in, and hopefully this will help to see thoughts for what might fit with the Agri-Tech Catalyst, which we're going on to describe a bit later on. So this represents a project which was funded through the first competition, the New Approaches to Crop Protection call, and it was a large collaborative R&D project which was led by Syngenta. And it was looking at ways in which you could develop sensors to detect oilseed rape pathogens, stem rot pathogen. And essentially what it was using was exploiting knowledge of the life cycle of this stem rot pathogen and developing sensor technology that would identify spores, but it actually measure oxalic acid, which is a signal for germination of spores. So rather than total spore count, it was actually showing the onset and threat of disease through that spore germination. So this particular project is now closed because it's one of the early projects that launched, I think, just at the start of 2010. And they've developed a number of prototype models. You can see one here, and they've done some trial work with Rockenstead and other partners. They've now got 10 of these prototypes available. They're looking to really further identify how it can be used to help measure and assess and monitor disease solutions to that threat, particularly in oilseed rape, but how they could use that technology to identify the pathogens affecting different crops in the UK. This project here was funded through the Sustainable Protein Production Competition, and it's led by M&8, which is an SME based in Nottingham. And they were looking at the challenge around fish meal and sustainability issues around fish meal for agriculture production, particularly in Scotland for the salmon industry. So they were looking at ways in which they could use novel fermentation technologies that they've got within the company to essentially make plant-based protein more bioavailable for salmon. So it's to enhance the amino acid profiles and the protein availability for those farm fish applications. But they're also looking at taking novel sources of microalgae to also include that in the feed compound to try and replace fish meal. Those two previous were large country R&D competitions. This represents a feasibility study, so it's a 12-month project through the measurement technologies competition. And whilst the others had a number of different partners, this is just a two-partner collaboration. So it's a plant breeding company with a university-based company. And it's looking at taking forward digital imaging technologies to help fast-track phenotyping in root crops to identify fungal pathogens, initially in parsnips, but it's then looking to roll that out across different root crops that they have and then onto leafy brassica crops. So it's trying to take away some of the monotony that you get and potential bias, human bias that you have within breeding programs, and fast-track that and link it into some of the molecular-assisted breeding programs that they're developing within the plant breeding company. This is a large collaborative project, but again it's just two partners, so it's one industry partner and a research-based partner. So it's using a dairy consultancy business and a research-based partner trying to look at imaging technologies to help monitor welfare within a dairy herd, to help provide better information to inform nutrient management, but also earlier onset to detect disease, and therefore to improve productivity and welfare and profitability within the herd. And then lastly, this is a very large consortium that involves optics companies, it involves LED light manufacturers, vertical horticulture companies, and again a university-based partner. And it's looking at quite a neat system where you've got LED lighting but also sensors to monitor plant growth of high-value horticultural crops. And it's going to allow people to have this what's termed just-in-time harvesting. So it's modifying light recipes so that they can be tuned to the specific needs of the crop, so that you'll get a more uniform harvest of that crop, you'll reduce waste, increase profitability, and reduce the energy input, because with LED lights you've got very specific wavelengths and reduced energy consumption compared to sodium lamps. And it links back to the university-based partner that's looking to try and identify tomato varieties that might be better optimised to this form of lighting system. Okay, so that's where we've been before. Where we're looking at next is around the challenge of competitiveness within the UK agricultural system, and within the Agri-Tech strategy that was published last year, it's recognised that within the UK we're now starting to lag behind some of our international competitors in terms of total productivity growth within the UK across crop and livestock systems. And the yield gap is often used to describe the difference between yield potential and the actual yields that are averaged on farms within the UK. And whilst we recognise that this is a multifaceted challenge, the effective control of diseases plays an integral part in trying to realise yield potential, both within crop and livestock systems. And that's what we're looking to move towards with the next competition. So what our thoughts are for this is, again, to look at large collaborative R&D type projects, to stimulate both innovative technologies but also different approaches and management decision making that can help improve the effective treatment of diseases and pathogens. And it's looking to focus on the primary causal agents of disease, so whether this is viruses, bacteria, fungi, nematodes, or essentially insects as vectors of disease. To try and bring forward technologies to identify the detection of pathogens, because we recognise that this can also inform disease management decisions on farms, and it's relevant to tackling the challenge. So, in terms of what this looks like, we've been doing some scoping work with the KTN, industry groups, levy bodies, etc. And some of the three main themes that's been falling out of this is issues around disease identification and assessment, so ways in which we can improve the diagnostics for pathogen strain identification, or ways to detect pathogens that might be resistant to particular treatments, control treatments. We're also looking at disease prediction, management and control as another strand, so including things like data capture, decision support systems to help optimise treatment plans, so things like frequency or the concentration of the actives being used to tackle a particular strain, integrated disease management approaches, various tools like ICT or sensor technologies to give you better surveillance systems, for the earlier or improved information to enhance your decision making about your treatment plan again. And then looking right the way through to prevention of disease or treatment of disease. So this could be through breeding programs, biotechnology approaches, or vaccine production. Ways in which you might be able to enhance innate defence mechanisms within crops or livestock through feed additives or bioactives or immunomodulators, or other approaches that we might be able to take to help avoid pathogen resistance through, if you like, the prophylactic treatments that can be routinely used in different production systems. So that's where we're thinking going next. In terms of the costs and the dates, we're still finalising these, but it's just to flag it up that this is something that's likely to be coming through a bit later on this year through the summer. In terms of other aspects, we're looking at all things that could be relevant to these broad themes to meet the challenge, including vector control. So I now want to focus more on the Agri-Tech strategy and a couple of the funding recommendations that fell out of that. So you're probably all aware that the strategy was launched last year. It really aims to improve the translation of research through to practical applications within agriculture, so to help meet the sustainable intensification of agriculture and the way in which the UK and UK agri-businesses can help to lead the way within this to meet that challenge. So the government recognised this as a key area for support and have put 160 million of investment behind it. And there were two key funding recommendations within the Agri-Tech strategy. I think Action 3 was for the Agri-Tech Catalyst to be formed, which represents a 70 million investment, and also Centres for Agriculture Innovation, which is a 90 million investment. And this is part of the UK industrial strategy now. So the Catalyst itself, I'm going to focus on the Catalyst rather than the Centres. It's opened last year. Round 1 is now essentially closed to applications, but round 2 opened on the 20th of January. And this is run by ourselves at TSB, in partnership with the BDSRC and also DFID. And we're really looking to help support businesses to develop innovative solutions to global agricultural challenges. There are a range of different award categories, and registration deadline, just to be aware of, for round 2. There's a first stage deadline in June, 4th of June, and then deadline for applications on the 11th of June. And in terms of the Catalyst itself, it's recognised within the strategy that agricultural science and technology is one of the world's fastest growing and exciting markets, which is driven by a range of different macroeconomic trends, such as a rising global population, rapid development in emerging economies, and changes to, if you like, diet preferences, which are putting different pressures on global resources and agricultural production. There is a need and competition around things like land, energy, water for productivity, and this really pushes into things like resource use efficiency and ways in which we can make production systems leaner and fitter for those types of elements. There are also things around climate change and extreme weather events. And this strategy is really recognising this, and it's trying to drive the UK to be at the forefront of the sustainable intensification of agriculture, and ways in which the Catalyst particularly can help stimulate UK businesses and the research base to develop solutions to this. So if we look just more generically at the Catalyst and the Catalyst model, these are a mechanism which is run jointly by ourselves at the Technology Strategy Board with research councils, and they essentially provide R&D funding to support a specific priority area where we're clear that we've got a leading position within the UK research base, but also UK industry capacity, so therefore commercial potential, and it provides this pipeline or escalator to take forward projects from, if you like, concept to early stage ideas, right the way to as close as commercialisation as we can. The first example of the catalyst that we ran was the biomedical catalyst, which was between the TSB and the Medical Research Council. The IB catalyst, the Industrial Biotechnology Catalyst, also launched earlier this month. And within the Agri-Tech Catalyst itself, we're really looking at ways in which we can support businesses and academia really to bring projects and ideas forward to meet this sustainable intensification challenge. So there's different award types, from early stage to industrial research to later stage experimental development and demonstration type activities. And within the catalyst itself, it's an ongoing process, so we're essentially running a series of different rounds around this sustainable intensification challenge. So within the catalyst, it's a 70 million investment, and it provides funding for collaborative projects it's not got any technology bias or sector bias, as long as there's an opportunity to meet this sustainable intensification challenge around agriculture. And we're really looking at all projects having an industry partner, but the research base can be involved as well. There's 60 million from TSB and DBSRC, who, as I said before, we're working in partnership with the Agri-Tech Catalyst, but there's 10 million specifically from DFID, so the Department for International Development, to help translate technologies and products and move those towards opportunities within developing countries to benefit from the R&D that's coming through. So in terms of the scope, it's a very broad scope of the Catalyst itself. So it will look at funding all proposals relevant to primary crop and livestock production, and agriculture is within scope within that remit. It'll also look at non-food uses of crops, so this could be from the arable, horticultural, ornamental sector, and things, for example, around sugar beet refining, pulling out streams like betaine, which is a high-value product which is used in the agriculture industry. It can include applications like that, so whether that's breeding high betaine varieties of sugar beets or the processes that help to take off these streams. But the thing to remember is it's how we're going to drive profitability through to UK agri-tech businesses. That's what we're really trying to do through this mechanism. From DFID's perspective, they're keen to look at food security and nutrition challenges for international development. And you could also look at solving some downstream challenges for food processing sectors, provided that the solution lies in primary production. So an example of this could be some of the breeding work in barley to reduce glycosidic nitrile levels to safeguard the export Scotch whisky market around potential legislation coming in from the US. So in terms of what's out of scope, we won't fund things relating to equine-related proposals, forestry proposals or wild capture fisheries, and support's available from any sector or relevant discipline as long as you can address the relevant challenges relating to sustainable intensification. Multidisciplinary collaborations are encouraged. So just around DFID and DFID's interest in their international development objectives, they're looking at things relating to sustainable reduction of poverty and hunger for smallholder farmers in developing countries, or the sustainable intensification of agriculture within developing countries, ways in which we can improve human health and diversity in diet and nutrition, projects that can help provide a positive impact on rural income and food security, or ways in which we can facilitate or enhance trade of agricultural products. In terms of the operation itself, there are going to be three main grant award categories. So we've got early stage awards, so this will be up to 18-month feasibility studies. Industrial research awards, so this is classical collaborative R&D, business-led R&D, and late stage awards for experimental development. We've said before, this is to provide a pipeline to help take forward things from the early stage exploration of a scientific idea or technical approach, right the way through to demonstration type activities, so field-based testing or prototype development prior to commercialisation. We'll have a range and a series of rounds, so this is the rolling basis on which the catalyst will evolve. And you don't need to have gone in, if you like, at this early stage to progress. You need to look at the project and the awards, the grant award category that's most relevant to the project. So it could be, for example, as some of these earlier SAF IP projects mature, some of the late stage awards are relevant to them. So there's no a priori need, if you like, to get in on the start and progress through. You can look at the most relevant award category to you and the project that you want to take forward. So this slide essentially provides you with a summary of the different award categories and some of the key requirements for those awards. This is available on Underscore Connect within the Agri-Tech flyer. I think we've got some hard copies here, but there'll also be links to each of these early stage awards on Connect, and I'll send you some slides with the links on that later on, which I think David can make available to you. But essentially within the early stage awards here, we're really looking at exploring the commercial potential of an early stage scientific idea. These projects can be academic or business-led, so unlike our other industrial research programs which need to have a business lead, they can have an academic-led partner, but you must have a business partner involved in that collaboration. They can't be academic to academic. You need a business partner there. They're up to 18 months in duration. Total project costs of up to £500,000. The total academic partner costs must not exceed 50% of the total project costs. And in terms of the grant intervention rate for businesses, for SMEs, there's up to 75% of their total eligible project costs, and for large companies, it's 65% of their larger project costs. So we've got this decreasing grant intervention rate, the closer towards the marketplace that we get. If we look at the Industrial Research Awards, you might be more familiar with this if you've been involved in SAP IP before, but these are essentially to help take forward the assessment and development of R&D relevant to the sustainable intensification of agriculture. The projects have to be business-led. In terms of timelines, they're between 3 and 5 years in duration, and up to 3 million in total project costs. Academics can't exceed 50% of the total project costs, so if it's a multi-academic partner collaboration, it's the sum of those partners can't exceed the 50% cap of the total project costs. And for the business partners, up to 60% of total eligible project costs for SMEs and 50% for large companies. And then moving on from the outputs industrial research or demonstration type activities, we've got late stage awards, and these are really to evaluate and explore what the commercial potential of things that might have come out of industrial research, or it could be projects which have been privately funded within industry, are within a more field-based type demonstration setting. So we have 2 different award categories for the late stage awards. We have pre-experimental feasibility studies, and these are up to 12 months in duration, and they're really looking at the evaluation of the commercial potential of a particular project. They need to be business collaborative projects, so academics can only participate as a subcontractor. And with these early stage feasibility studies, they're up to £500,000 in terms of the grants, and there's a lower grant intervention rate for industry, so 50% for SMEs with the total eligible project costs and 40% for large partners. And then the experimental development, this is more to do with the actual evaluation and really looking at how those projects would be demonstrated and the commercial potential in the field setting. So it's up to 12 months duration, up to £1 million in terms of total project costs. Again, academics can participate by subcontractors to businesses, and it's collaborative again. There's this lower grant intervention rate, so it's 35% of total project costs for SMEs and 25% for large corporates. So to say, an awful lot of information, if you think this is something that might be relevant to you, is available on _Connect. So if you want more details, there are links to the early stage awards, industrial research awards, and the late stage awards. And there's also the guides for applicants, which you can look at as well. And as David said at the start, this is one of a series of roadshow events we're doing to promote the Catalyst. Obviously we're here at Edinburgh today, but if you've got colleagues that couldn't make this event, there's still an opportunity to engage. So we've got another event on the 11th of Feb at Cardiff, 14th of Feb, I say Romance is Dead in Peterborough, but if you're lucky, give you a kiss and a cuddle in the corner. And then the 17th of Feb, we're in Belfast. So we've got the registration links here as well. Peterborough sold, yeah. Okay. So if you want to go to Peterborough, you might not get that, but you can get on a waiting list for the event. So the key dates, as we said, it's open 20th of January. There will be a briefing webinar as well, where you'll get more information specifically about the application process and some of the rules and regulations related to that. We will go through that a bit later on, but we'll have competition staff to really go through that in an awful lot of detail. So it's probably something in terms of make a note of that for your diary, and that will be a virtual webinar, so you can just dial in. Hopefully it shouldn't be too onerous in terms of your time commitments with travel. Registration deadline for the current round 2 is the 4th of June. For the early stage and late stage that we spoke about, that's a one-stage award, so a one-stage review process for the applications. So the deadlines for those are the 11th of June. For the industrial research strands, it's an expression of interest and also a full-stage award. So the first stage will be sifted, and if you're successful at expression of interest stage, you'll be invited to put an application into the full stage process, which is opening on 14th of July, and the deadline for those applications is the 2nd of September. And then I think the other thing just to be aware of, I'm sure some of you are already, is to flag up that the KTN's knowledge transfer networks do represent a really useful resource to help you both with identifying partners for a particular application, but also they can help you in terms of a critique of potential proposals to the competitions. So they can't actually write anything from the bottom up, but if you want to get some feedback, some really valuable feedback about the fit with the competition, do look at the KTNs for all that service. I've just put some of the people involved in the biosciences KTNs, so David, who's been helping us, and Serena, who's been helping us to organise these workshops. There's obviously Kezia and Aurora and Amy here as well today. So if you don't already know them, I'd encourage you to get to know them and exchange contact details, because they're a real asset for the process. And also some people here for the ESP KTN who've helped us with previous competitions. Alex and Mark, it's worth looking at those, maybe more on the measurement diagnostic side, but they're another valuable resource as well.